we will be exploring the experimentation of calorimetry.
So we had to have a baseline calorimeter. So we start off with a insulation, which is a pool cover with duct tape. And then we decided to use an aluminum pop can with the top cut it off and just hold around for safety. And then a large white tea light because it had the highest flame out of the two tea lights that we could find. And so for our experiment we had to change one variable. So the variable we decided to change was the heat capacity of the container that was actually holding the water. So not only did we use the aluminum can, we also used a glass beaker and a tin soup can.
Now let's go over to Matt and see how this thing is put together.
Thanks, Ben. You see, first we started off with some tea light candles. You can get these pretty much anywhere. Second, we took a container, ours is a pop can, and you fill it with water. And thirdly, we have our insulation. This was made out of pool cover that we took a sheet of, cut it off, and then rolled it into a cylinder with a lid on top to prevent airflow escape. When we're setting up our system, we have the candle surrounded by stoppers, or stands, and then the can with the water in it will go inside and sit over top of the flame, putting the heat from the flame through the can into the water so that we can measure the heat transfer. And now we'll pass it off to Ben, who will explain the methods of heat transfer in this experiment.
Thanks, Matt. Now, there are three major ways to heat something up: conduction, convection, and radiation. Now, with conduction, the flame heats up our container, any of these three objects, and heats that object up, which then transfers its heat into the water. That's how we use conduction. Now, convection, this is where the insulation comes in. The heat can't escape out the top of this, so it's forced to stay inside the insulation and then heat up the water. Now, we didn't use heat transfer through radiation because we believe that its effects would be negligible on our calorimeter. Now I'm going to pass it off to Matt and Brent for our final conclusion.
Thanks, Ben.
We now have the results. We found out what the lowest heat capacity is.
The lowest heat capacity is the glass beaker. This means that the water heats up the quickest when it's in the glass beaker.
The second lowest heat capacity is the tin. The highest heat capacity was the aluminum can.
And now off to Matt and Ben for our next steps in this experiment.
Thanks, Brent. And now on to our next steps.
Next time, what we're going to do is we're going to change the container holding the water into something a little bit more unique. Dr. Bunsen Honeydew and his lab assistant Beaker have been working on a flame-proof paper that we think would be quite interesting.
Let's go see what they've been up to.
Dr. Bunsen Honeydew here at Muppet Labs, where the future is being made today. Well, jeepers, you're about to witness the world's first demonstration of fireproof paper. Here is my assistant Beaker carrying a lighted blowtorch. He will now show you how impossible it is to ignite the fireproof paper in this basket. There is no way this paper can burn. With Muppet's fireproof paper, you will always feel secure. Tune in next time and witness Muppet Lab's new answer to the energy crisis, flammable water. That's all for now from Muppet Labs. Oh dear. Oh.
So we've decided to change our next steps to something else.
Something a little safer. We're going to change the liquid that we're heating into something like oil or vinegar.
So we'll let you know how that goes. See you next time.